Welcome back to this series on binomial theorem. In the previous videos, we've looked at Pascal's triangle and how it helps us to know the coefficient of each of the terms in our expansion. But it's obvious that we may not be able to physically draw the Pascal's triangle every single time, especially if the power, which is our n, is greater than 5 or 6. So today we are going to look at how we can still apply the principles of the Pascal's triangle without drawing it. In order not to get too technical, we're going to take it step by step. And the first step is remembering or recalling what we call the factorial. In mathematics, the factorial is represented by this exclamation mark, and I'll show you how it works. If I say 4 factorial, what I mean is 4 times the number less than 4, which is 3, times the number less than 3, which is 2, all the way to 1. So 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. If I say 6 factorial, I mean 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. 360 times 2 is 720. 720 times 1 is still 720. Now, the factorial is mainly used when we are referring to permutation and combination. And the Pascal's triangle is actually an application of combinatorial mathematics, where you're looking at all the different combinations when you multiply the first term in your expression, which is x, and the next term, which is a in this case. So each expression is actually n combination r. And n combination r is n factorial divided by n minus r factorial times r factorial. Don't get fazed by this. You just remember it, you know what a factorial means, and you can work with it. Now the n doesn't change because the n here is this same n, the power of our expression, but the r changes. The r is the position of the term. So let's say n equals 2, which means we are looking at x plus a power 2. Remember I said that the n doesn't change. So what we'll be dealing with is 2 combination r. For the first term of our expansion, r will be equal to 0. Remember that even with the Pascal triangle, we started at level 0. So in the first term, we will have 2 combination 0. And looking at the formula, that gives us 2 factorial divided by 2 minus 0 factorial 0 factorial.
0 factorial equals 1. So every time we see 0 factorial, we can easily ignore it. Since we have 2 factorial divided by 2 factorial, our answer is 1.
So that's how we get that our first coefficient is 1. So for the next term in our expansion, the next term in the final answer, the r will be 1. So it becomes 2 combination 1, which is 2 factorial divided by 2 minus 1 factorial 1 factorial, which is 2 times 1 divided by 2 minus 1 is 1, and 1 factorial is 1, and then another 1 factorial is 1. So the answer here is 2. And then for the last term, which is 2 combination 2, once n and r are equal, you know that that's your last term. That would be 2 factorial divided by 2 minus 2 factorial times 2 factorial. Again, 2 minus 2 is 0, right? So that's a 0 factorial.
Since we have 2 factorial divided by 2 factorial, our answer is 1.
The answer is 1. If you recall from the Pascal triangle, which I can just give you a refresher here, you can see that these coefficients correspond with these 1, 2, 1. We'll try another one when n equals 4. When n equals 4, remember r will move from 0 all the way to 4. So in the first instance, you have 4 combination 0, which is 4 factorial divided by 4 minus 0 factorial 0 factorial.
Since we have 4 factorial divided by 4 factorial, our answer is 1.
For 4 combination 1, we will have 4 factorial divided by 4 minus 1 factorial 1 factorial. This is 4 times 3 factorial divided by 4 minus 1 is 3 factorial times 1 factorial. I left this as 3 factorial so that I can easily cancel out, and our result is 4. 4 combination 2 gives 4 factorial divided by 4 minus 2 factorial 2 factorial, and that's 4 times 3 times 2 factorial divided by 2 factorial 2 factorial. This will cancel this. 2 factorial is actually 2 because 2 times 1 is 2. So this can take off from here. And what you have is 2 times 3, which is 6. 4 combination 3 gives 4 factorial divided by 4 minus 3 factorial 3 factorial, which is 4 times 3 factorial divided by 1 factorial 3 factorial. 3 and 3 will cancel, and the result is 4. And lastly, 4 combination 4 would give us 4 factorial divided by 4 minus 4 factorial 4 factorial.
Because we have 4 factorial divided by 4 factorial, it will give us 1.
So you see you have 1, 4, 6, 4, 1, which is the same as we would have gotten if we had drawn the Pascal triangle.